Hello, Tungsten Miner here. Last time I left off, we had just covered the various kinds of windmills and early game power systems, the water wheel here. So now let's jump back in and get into the wiring systems. Next, let's talk about wiring. So over here, I've got an engineer's voltmeter and engineer's wire cutters. So I'm going to take those out of the box here, and I'm going to grab myself some LV wire. And here I've got an LV capacitor. We've been talking about these a little bit. They can store a decent amount of power. Let's just take a look there. Basic wiring. Okay, yep, I'm talking about wiring. We'll get to that in a minute. Okay, so here's our capacitors. Basically, they all have the same recipe: iron, copper, lead, and redstone, along with treated wood. This gets bigger. Eventually you need a redstone block. This gets bigger. Eventually you need a lead block, and so on as you go through the different ones. So these materials on the sides here change as well. Electrum and what was it? Aluminum, I think. Yeah. And steel at the top. So the materials get more expensive, but the basic recipe is the same. And the thing that capacitors do is to store power. Yeah, they don't tell us in the book here exactly how much, but with our engineer's voltmeter, which, yeah, we talked about the recipe already, I can just point it at anything that has the capability of holding charge and see how much charge it currently has. So this one has 0 out of a possible 100,000, 100K RF. This one is the medium voltage capacitor, and it can store 1 million RF. And this is the high voltage capacitor, and it can store 4 million RF. Okay, now each of these have their own wiring systems. Here's a low voltage connector with a low voltage wire. And we can see that goes for a total of 16 meters before it has to connect to something else. If I had moved this even one block further away, it would be too far. I'm also using the wooden poles here to show off how the connectors can be placed. So either you can hang them underneath, you can put them up on top, or you can even put them directly on top of the pole, or you can put a connector on the bottom of one of those balloons and hang the wire in the sky. Next up, medium voltage. You can see the connector looks a little different. There's the two of them right next to each other. And the big difference between the different kinds of wires is how much power they can transfer. So each connector can take 256, 1024, or 4096 RF per tick as input, and the wires likewise have different transfer rates. So you can have more than one wire carrying power from one place to another, but they all have their maximums. They also have different efficiencies. So there's, I don't think it's in the book here, doesn't look like it. But each of the wires will lose a little bit of power over the distance that it travels. So if you're moving just from one connector to another connector to another connector to another connector, you're actually going to be losing a little bit of power from one to the other. The medium voltage loses a little bit less power, and the high voltage loses less power still. Except it's not quite that simple. If you aren't using, I think, more than half the capacity of the wire, then the loss becomes much, much greater. So if you're using high voltage cables and transferring a tiny amount of power, your loss is going to be really prodigious. And you might want to step back down to medium voltage cables for moving less amounts of power. Our high voltage cables actually can go quite a bit further. So this is going to make a 32-meter stretch at a glance. And they have a different kind of intermediate connector. You can't just go like you can with these guys with the same connectors the whole way. So this guy is required to be in the middle. And if we look at our high voltage systems here, we can see, oops, let me grab a few of those. There we go. Actually, let me also get some of the cable. All right, and the recipe for the high voltage wire relay is hardened clay with aluminum in the middle instead of copper, and you need 6 of them instead of 4. And then this guy requires this insulating glass and iron. And the insulating glass is iron grit, some glass, and some green dye of whatever kind. And that gets you the glass. So high voltage is a bit more expensive, but you can go a lot further and you can transfer a lot more power with it. Next up, let's talk about some electrical devices that are handy to have. So here I've got just a LV capacitor providing power going to this breaker switch. And just as you might expect, when the breaker is open, there's no power being transferred. And if I right-click on it, the breaker closes, and now there is power being transferred up to the maximum of the wire minus the loss from the distance. And if I open the switch, no more power transfer. Over here, we've got basically the same setup with high voltage. And for high voltage, you can't use that switch. It's just not sturdy enough. So instead, you have to use this redstone switch. And this guy only works, as you might guess from the name, with a redstone signal. So right now, there's no power transfer. Come back here, flip the switch, and now there's quite a lot of power transfer. The 4096 minus the loss. Turn it off. That goes off. Okay, next thing to talk about, electrical devices. Here we are moving through various transformers. And these transformers, this is a regular transformer and that's a high voltage transformer. Unfortunately, they look virtually the same, so it's kind of hard to tell them apart. But here we started with a low voltage battery, low voltage connector, low voltage wire, and the transformer allows you to switch from one to another. Because if I have a medium voltage connector, I can't hook up low voltage wires to it. And if I have a high voltage connector, I can't hook up medium voltage wires to it. So this allows you to jump from a low voltage system, which maybe is powering devices in your house, to a medium voltage system, which is maybe what you're using to move power long distances because it's more efficient. So here we've moved using medium voltage wire and medium voltage connectors to a medium voltage capacitor, back to the high voltage transformer, which you can actually see has a medium voltage and a high voltage side. I didn't actually have to do that, by the way. It just kind of does that automatically on its own. Another thing to note is that when you're connecting wires, you right-click directly on this connector, but not on that one. You have to click on the top part of the box here for the connection to be made. And then finally, we've got a high voltage cable going to our high voltage capacitor. So here's a little system that goes all the way through the different voltages using 2 transformers to make the jumps. Okay, next up, we're going to talk about this thermoelectric generator. Basically, it's just a block that allows you to make power from a difference in temperature. So obviously, I've got lava on one side and I've got water on the other side, which gives me a difference in temperature. And if I were to look up my thermoelectric generator, that's this guy. Here we've got some steel ingots, that copper wire coil, and the Constantan plate. The recipe for this guy is you take some Constantan ingot, which is crafted by smelting grit, which is made by ferrous metal and copper. So nickel and copper basically mixed together gets you Constantan grit. And then you smelt that the usual way. You can craft any metal with your hammer and get a plate, and various recipes will call for that. And then finally, you can take that with some steel and craft that into your thermoelectric generator. Then you place things of 2 different temperatures on either side. And there's a whole lot of different things that you can use. So if we look up our book here, our thermoelectric generator has a little table in it that shows you the temperatures of various items in the game. And you notice lava and water are not listed here. So these are things apart from fluid blocks. So molten metal maybe would work. Any kind of hot or coldish thing that is in there, you can try out. These are the ones that are definitely available in my particular mod pack. I believe this book is pretty smart about reading data from whatever mods you've got installed. So if you've got, say, Industrial Craft installed, you might see some Industrial Craft blocks show up in here. I happen to have big reactors installed, so you see yellorium and plutonium and so on installed here. Anyway, so what's going on here, let me throw this breaker, allow the power to go through, is we're getting 14 RF per tick just from this block sitting here. So it's completely renewable. And of course, if I had a whole bunch of these things stacked on top of each other with lots of lava and water on both sides, that would work even better. If I was using, say, packed ice along with plutonium instead of lava, I'd probably be getting much better power results still. So you can experiment with these things in order to generate power from temperature differentials. Okay, next up is this lightning rod. You can see I've got a tower made out of this steel fence, and all of those blocks up there likewise are steel fence. And there's no particular pattern you have to make them in, but the broader the network of steel fencing you make at that very, very top level, the more likely you are to be able to harness a lightning strike and have it come down to this block. Now, this is the second multi-block that we've run into, and this one is unassembled. So you can see these are all lightning rod base blocks. As soon as I right-click with my engineering hammer in the center, I believe, it turns into the multi-block structure. And you can see all the patterns have changed, and this is definitely now an actual lightning rod. This thing can store up to, I think, 16 million RF. Yeah, there you go. And it gets that by being hit by lightning. And then it will slowly, at high voltage capacity transfer rates, move power out and through the rest of the system. So if I turn on the rain here, I can sit back and we can wait a while and see if any lightning is going to wind up striking this thing. I'll fast forward to a point when that actually happens. Okay, that looks like it might have actually hit, so let's take a look here. Aha. So we now have 15 million RF. Boom, just one strike, and we've got all that power in this lightning rod base. We are now moving maximum high voltage throughput, minus the loss, and that's getting stored into this HV capacitor, which is now at 2 million and rising power. There's a lot of power in the base of that thing, right? I mean, there's, what, 15 million RF waiting. So it's going to fill up this capacitor and then some. And really what you can do is just use that as your main source of capacity. And that way you've got a lot of storage. But, you know, it doesn't rain all that often in Minecraft. And lightning strikes are not all that common. So not a super reliable source of power, but a really nice way to build up some extra power now and then. Let me turn off the rain here. In case you're wondering, this actually is just a command block buried underneath here that I've set to have the command for changing the weather using the console commands. Let's talk about fluid movement. So here we're looking at a fluid pump connected to a fluid pipe, which is connected to an unformed multi-block structure for storing fluids. So if I right-click on the middle block here, it's going to turn it into a tank. And this tank can store whatever fluid you move into it. And these fluid pipes work like fluid pipes in any other mod that you might expect. The pump itself can be configured to output on various sides. So I've got this orange output connected to my pipe here. I've got a blue input side underneath facing the bottom. I've got just some basic power coming in and powering into the top of the pump so that when I give it a redstone signal, it's immediately going to start pumping water out of this little pool down here and transferring it into my tank. And you can see that little blue sliver just starting to creep its way up as it transfers in. Now on the other side, I've also got pipes connected and a Buildcraft tank. And Buildcraft tank, just because it's nice and clear, it's easy to see what's going on. And if you provide a redstone signal to this bottommost block on the tank, it will start pumping fluid out of the tank. And right away you can see it's starting to fill up that Buildcraft tank on the far side. And as soon as I throw the switch, it stops. And over here, this pump is still carrying on. It's smart enough to recognize that water is going to auto refill itself the way it does in Minecraft, and so it's not moving the blocks out. If this were some other fluid, it would actually remove the blocks. So lava, for example, would take all the blocks out and move them into the tank. Fluid pipes can be surrounded with any kind of scaffolding. So wooden scaffolding, steel scaffolding, and aluminum scaffolding are all available through immersive engineering. So what we're looking at here, these are the scaffolding blocks. Here's a scaffolding block which I've right-clicked on the pipe there. You can kind of see it inside. And these are structural arms, which again you can make from treated wood, steel, and aluminum. These work just like treated scaffolds in that you can climb up the sides of them. You can craft them with a little bit of treated wood to get this nice wooden top instead of the raw, open structural appearance. And very handy for making nice looking, say, oil derricks or pumping stations or whatever else, a much more industrial sort of look. The treated wood ones are nice for an older style look. Okay, next up, we have a multi-block structure which is about to become a silo. So if I right-click on this middle block here, I don't know why they keep knocking the levers off. This becomes a silo. Now a silo is a structure that can store, gosh, like 32,000, some enormous amount of any one item that you want. So just like a tank can store any amount of, well, up to 512 buckets worth of any one fluid, these things can store up to many, many stacks worth of any one item. Apart from that, though, they work kind of the same way. So here I've got some wheat, say, we wanted to put in our silo. And I'm going to toss a few pieces of wheat onto this conveyor belt here. I think this is the first time we've seen conveyor belts, so let's talk about them for a second. Conveyor belts are an item added by Immersive Engineering that allows you to move items. Except unlike, say, pipes or something that you might see in other mods, you can actually see the items moving along. Fairly simple to make, just some leather, some iron, and redstone. Any item that gets tossed on them will get moved along. And you can place them one next to another so that this one, say, drops it onto this one, which moves it off in a different direction. As you can see here, you can form ramps out of them just by putting one here, and then there, and so on. They'll automatically bevel and tilt themselves. I can use my hammer to change their direction, and if I shift-click with my hammer, I can change the angle that it's at. So that's all back to normal here. At the top of my conveyor, and you notice, of course, that they can move me along as well as animals, I've got a dropping conveyor belt. So if you craft a hopper and a conveyor belt together, it forms a conveyor belt that basically works like a hopper. You know, if there's any inventory underneath it, it's going to drop whatever that item is into that inventory. And of course, underneath I've got my silo, and the silo is able to accept items either from the sides on the bottom here. Silos can't. Tanks can accept items basically either from dropping them into the top with some kind of fluid pipe or piping them into the bottom. Items can be removed only from the bottom. For a silo, items can only be added to the top and only removed from the bottom. And like with the tanks, you need to provide a redstone signal to start getting the items out again. And as you do that, you can see the count on the side of the silo is going down until the silo is no longer dedicated to wheat because there's no particular item in there. I could throw anything I wanted in there now. Okay, that's it for our moving things around systems. And let's say that's it for this video. So this time we've covered a lot of the basic wiring. We've covered some of the more interesting and esoteric ways of acquiring power, systems for moving fluids and items around, and a little bit of item and fluid storage. Next time, we're going to jump in with the blast furnace and various ways to produce steel and a whole bunch of other things, getting into some of the heavy machinery that comes with the mod. So if you like this video, hit like. If you want to know when that next video is ready, hit subscribe, and I will talk to you later.